Hi, this video I'm going to tell about the memory management strategies. First, I will tell about the background about memory management. So, normally when we write a program, so the program is stored in secondary memory. So, once we are going to execute a program, that must be brought from secondary memory into main memory and placed within the process for it to be run. So, here, how many memory access will take place. So there are different registers available like secondary memory, main memory, cache memory and CPU registers. So here main memory and registers are the only storage CPU can access directly. So the registers is actually inbuilt within the CPU and main memory. So these two are CPU can access directly. So the memory unit only sees a stream of addresses, that is a physical address plus read request or address plus data and write request. So this only the memory unit can see. So normally how many clock cycle every access will take place is, for register access the CPU can take only one clock cycle. Suppose our data or instructions are available in main memory, it may take many cycles. It will cause us a stall. So stall we may study in pipelining. So the cache memory actually sits between main memory and the CPU registers. So what we need is, we need to protect a memory to ensure correct operation. So for that we are using two type of registers in CPU. One is a base register and other one is a limit registers. So this pair of registers define the logical address space. So logical address means the CPU generated address is called as logical address. So the logical address space actually contains a pair of base and limit registers. So whenever the CPU generates an address, it must check every memory access generated in user mode to be sure that is in between base and limit registers for that user. So for example, assume that here I have three processes. This is process number 1 and this is process number 2 and this is process number 3. So for every process we have a base register. So base means it is a starting address of that particular process. So limit means that size, that will be the limit. So here actually, for example, the process 2, the base register, base address is 3 lakh 40 and the limit is 1 lakh 20,900. So how much space it will occupy is 3 lakhs 40 to 4 lakh 20,090. So base plus limit. So that space it will occupy in the memory. And here how we can provide the production hardware address production is, once a CPU generate an address, so that address is a logical address. First the CPU will verify that whether it is greater than or equal to the base register. So if it is less than the base register, so then it will trap to the operating system monitor for addressing the error. So that is an error actually. The logical address is if it is less than the base register, it is an error. In case if it is greater than base register, so then whatever the limit register, so that will be added with the base register. So base plus limit will be added and that address will be stored in the physical memory. So that is the main memory. And here we have an important concept of address binding. So what is address binding means, so in case once we complete the program writing, it is available on secondary memory. So once if you are going to execute a program, that should be ready to be brought into memory to execute from an input queue. So without support, it must be loaded into the starting address. So that is 0000. So it is inconvenient to have first user process physical address always at 00. We cannot store all the address in the say 0 starting address, that is 0000. So for that we need to generate different addresses. So addresses, we have three different types of address. So first one is symbolic address. So we may call it as, this address is called a symbolic address. Symbolic address means the source code generated address. So that address is usually symbolic. So during the compilation, compiled code address bind to relocatable address. So that address is called as relocatable address. That is 14 bytes from the beginning of this module. And the linker or loader will bind the relocatable address into absolute address. So that will be, that is 74014. That is 14 bytes from the starting address. So that address is called as absolute address. So we discussed about three address: symbolic address, relocatable address, and absolute address. And here address binding of instructions and data into memory. So address binding of instructions and data to memory addresses can happen at three different stages. One is during compile time, one is during load time, and another one during the execution time. Suppose if you are not knowing the memory location prior, if the memory location we know in prior, obsolete code can be generated. So must recompile code if the starting location changes. In load time, we must CPU generate a relocatable code if the memory location is not known during the compile time. In case memory location known during the compile time itself, obsolete code can be generated. In case memory location is not known during the compile time, then relocatable code will be generated. So then binding is delayed until runtime. If the process can be moved during its execution from one memory segment to another segment, then it is called as execution time. And here we are going to, I'm going to say about what is logical address, what is physical address. So logical address means the address generated by the CPU. That address is called as a logical address. The other name for the logical address is virtual address. Physical address means the address seen by the memory unit. That is a main memory. Whatever address seen by the main memory, that address is called as physical address. We have two different address space, logical address space and physical address space. So logical address space means it is set of all logical addresses generated by the program. So that is called a logical address space. Physical address space means it is a set of all physical addresses generated by the program. Now we have a memory management unit. So the purpose of memory management unit is to convert the logical address into physical address. That is a hardware. It is one of the hardware device that maps the virtual address into physical address. This is actually dynamic relocation using a relocation register. So during the execution time, that is during runtime, the routine is not loaded until it is called. Okay, so only when the routine is called, called, then only at that time only the routine will be loaded. So what is the advantage for dynamic allocation is a better memory space utilization. Unused routines are never loaded. Suppose we are loading that particular routine, if it is not at all used means then it is utilization is very wasted. So for that, for better memory space utilization, unused routine is never loaded. So all routines are kept on the disk in relocatable load format. Whenever it is necessary, the routine is loaded. So it is useful when the large amounts of codes are needed to handle infrequently occurring cases. So here is an example. So we have a CPU generated address, that is a logical address. So the address is 346. So now the relocation register, that is address value will be 14,000. So MMU will convert the logical address into physical address. That is, memory management unit maps the logical address into physical address. So both 14,000 and 346 is added, and 14,346 is loaded in the physical memory. And dynamic linking. What is dynamic linking means? We have two different types of linking. So static linking and dynamic linking. Static linking means system libraries and program code combined by the loader into binary program image. That is static linking. So dynamic linking means linking is postponed until execution time. So here we are using a small piece of code, that is a stub. It is used to locate the appropriate memory resident library routine. We have a swapping. The purpose of the swapping is whatever programs that are not necessary in main memory, that will be swapped out into backing store. Whatever program that is needed, that will be swapped into the main memory. The process can be swapped temporarily out of memory for a backing store and then brought back into memory for continued execution. So that is actually swapping. So here we are using the backing store. Backing store means it is a secondary storage device. It is a fast disk large enough to accommodate copies of all memory images for all the users. Here we are using the concept of rollout and roll in, that is swap out and swap in. Swapping variant used for priority based scheduling algorithms. For example, in priority scheduling, in case higher priority process comes, we are swapping out the lower priority process and swapping in the higher priority process. So that is actually the concept of rollout and roll in. The major part of swap time is a transfer time. So here the total transfer time is directly proportional to the amount of memory swapped. This is a schematic view of the swapping. So here we have a main memory. In this diagram, I have two processes, P1 and P2. So P1 is not necessary, means it is swapped out, and P2 is now necessary. It is swapping from backing store into the main memory. That's all. Thank you.